Hello everyone, I'm Lucas and I'm going to show you guys my undergrad project that I've been doing for 1 year, that is Moon g-2 within RS model. Well, since the Moon's g-2 collaboration at FamiLab published a paper in 2021 showing a 4.2 sigma tension between the standard model predictions for Moon g-2 and the experiment average taken at FamiLab, studying this topic has been one of the most important things in particle physics right now. And understanding the origin of this tension turns to be one important thing in this field. So I started studying this topic by performing one loop g-2 diagram. The technique that I used to compute these diagrams was the Fabian parameterization, the dimension regularization, and the Vic rotation. The first diagram that I performed into g-2 was the Schwinger's contribution to g-2 that he computed in 1948. And after that, I started studying the linear order electroweak contributions to Moon's g-2. Studying this topic, I noticed three important things that I'm going to comment with you at this moment. First of them was that the number of Feynman diagrams that contribute to g-2 depends on the electroweak gate choices. The first that showed that was Weinberg in 1971, and after that Fujikawa showed that too in 1972. Basically, using the Feynman-Toft diagram, Feynman-Toft gauge choice for electroweak contributions, and that is the gauge more easily gauge to compute these diagrams. We have to add at this theory the contributions to ghost bosons. So we have to compute two more diagrams with ghost bosons and W bosons using this the Feynman-Toft gauge choice. Second thing that I noticed is that the Higgs contribution to g-2 is very, very weak at this point. The precision of the experiments can't notice the first Higgs contribution. So it needs upgrades to understand and to visualize the first contribution from Higgs to Moon g-2. Third thing that I noticed is that computing the Higgs contribution using the integrals is very, very hard, because we can expand the integrals using simply methods to expand. And I need to use one more advanced method and more appropriate for these integrals, that is the Feynman-Barnes loop integrals expansion. Use this technique, I was able to expand this integral and to have the first correction to Higgs, that is this one. Well, after that, I start to understand and to study the hadronic vacuum contributions to g-2 based on the special relations. That is the focus that gives the tension that FamiLab shows in 2021. Perform this diagram right here, we use the optical theorem that related the photon propagator with the RS data. RS is basically the function that is related with the positrons, electrons, in hadrons cross sections. So writing this photon propagator using RS functions, we can use a dispersive relation to compute the hadronic vacuum polarization's contributions to Moon g-2. Use these dispersive relations right here that we compute directly from RS functions. How we can use the dispersion relations in RS functions? One way to calculate this is from RS dataset that the Moon Theory Initiative calculated in 2021 is the origin from the biggest tensions at this moment between the experiment average and the standard model predictions. You can compute the RS function using dataset. So you have the dataset from the hadronic cross sections, and you put this data on these integrals you can calculate, or you can use RS model. RS model that I choose to study is that Barucha, Boyd, and Melks constructed in 2021. That's basically a RS function based on the light quarks, UDS. They wrote the UDS contributions to RS based on between Wigner functions. There are functions that are related with resonances in the high energy physics. And you can notice from this figure that the results from the RS data and the RS model fits very well. And we can study this RS model and see if it fits the results for g-2 hadronic vacuum polarization's contributions. I calculated these RS models contributions to G-2 with the RS model, and I noticed that the result is very, very close to the result from Moon Theory Initiative G-2 using the RS dataset. That showed to us that this model needs more refinements, basically adding the other quarks contributions or refinements in the Breit-Wigner functions or calculations with the diagrams that I showed before. And that's it. That's my project. I hope you guys enjoyed. And I have to be thankful for IFSC and FAPESP for all the support.